Okay, hi everyone. My name is Salomon. I'm from Red Hat. I'm working on Ceph. And I want to talk a bit about public cloud economy. So it all started several months ago when we are an open source company. So my boss came to me and showed me some blog related to Ceph that was published, and he asked me, it was about read affinity, we'll talk about it later. And he asked me whether we can implement it. It's important for our customers on AWS. And it happened that it opened, well, let's call it can of worms. We could have more positive things. It's implementing on public cloud and reducing costs on public cloud is interesting topic, and with a lot of impacts that are not technical but are very important to the customers and should be designed by technical people. So this is my talk is about the less technical things that we need to do in order to support application for the public cloud, or it's technical for non-technical reasoning. We need to change our application for business reasoning. So I'm going to talk about mainly three things. Why we need storage application for the public cloud, just why we are not using the native cloud application. I'll talk mainly on AWS terminology. I have been working mainly on AWS. I looked at other clouds as well, but that's where I feel a bit more comfortable. So I'll talk about AWS. Most of the public clouds have very similar capabilities. We talk again a bit about the structure and economy. And most of the things would be some tips for developing economic applications, storage application for the public cloud. Many of the tips or some of the tips are generic, related to any public cloud application, but obviously I come from storage. It will be focused on storage, but Ceph is a distributed storage application. It uses it's not many things like network connections, things which relates to other applications as well. But it's interesting. Before I start, I have a question. I don't see many people who remember the Windows 3.x era. This is code example from the Windows era. It's the message loop, basic message loop of Windows. And the question is, what is the difference between get message and pick message? And the answer to this is, well, there is a technical answer, but basically there were code examples using this or this, and they were used interchangeably until something happened. And what actually happened is that laptop became more popular. And then it became apparent that pick message is not friendly for the power management subsystem, while get message is. So if your application used pick message, you were eating the battery of the laptop. So why do I bring this? Because it was something completely non-technical. No one knew about it, except if you worked within Microsoft Power Management Windows system or Intel or whatever. But suddenly you had to change your application because your application, which worked perfectly well, was not friendly to something new that happened, which is laptop or computers which were powered by battery. So it's a bit analogous to what happened in the public cloud. You may have applications working perfectly on your private cloud, but when you move them to the public cloud, the rules of the game have changed. And not necessarily they told us that the rules were changed, and we need to adapt to the new rules. And this is what I'm going to talk about. So why do we need storage application for the public cloud? There are various reasons for this. Efficient resource usage. If we look at what we can get from public cloud, from AWS, for example, we have a huge realm of possibilities, what we want, all kinds, all sizes of, if you're talking about block, all sizes of volumes and IOPS and everything, but we get only very few points from Amazon if you want to buy them. So EBS volumes come with fixed IOPS per size ratio. For each terabyte, you get 3,000 IOPS. So if you need 3,000 IOPS and only 100 megabyte, you pay for 1 terabyte with 3,000 IOPS. If you need 1 terabyte with 6,000 IOPS, you need to pay for 2 terabytes with 6,000 IOPS. So you can't mix and match. And if you have two applications, one which requires a lot of IOPS and the other require a lot of data, a lot of capacity, you need to pay both if you go to Amazon. They won't split it between the application. But if you provide your storage application to the public cloud, to your customer, you could take the one volume, which is large with a lot of IOPS, and slice it to your application according to their needs. There are other options in Amazon. And again, I didn't put here numbers because they change all the time, and they could change tomorrow if they didn't change today, and I'm not in charge of the pricing schemes. But so you could be charged on a fixed low price on your capacity, and then pay per IOP, pay per IOP per month. But then if you have a lot of IOs, again, you pay more. It's very difficult, unless you are really, really lucky, to get something that fits exactly your needs, especially if you have multiple applications over the cloud. If you have a storage system that could do slicing, it could get a lot of resources, enough resources, and split it between the application, you could have way more efficient way to use the expensive resources that you get from the public cloud. And I say expensive resources because basically the public cloud providers make a lot of money. So it's expensive relative to putting on your own. On the other hand, we all know that we move to the public cloud. So I'm not arguing why we do it, but it's expensive and we need to work efficiently to pay less. Multi-availability zone storage. Availability zone is kind of a data center in order you can deploy your system on multiple availability zones, so in multiple data centers for disaster recovery. But unfortunately, EBS volumes are limited to a single availability zone. So if you want to have disaster recovery capabilities, you need to add to this replication. On the other hand, if you have storage systems, software storage systems such as Ceph or others, you could implement them on multiple availability zone and have actually the effect of synchronous replication, as long as you are not really sensitive, very, very sensitive to the latency. So with little more latency, you get the effect of synchronous replication, which in any case, synchronous replication means more latency. But you don't need to pay for this, for the replication in this case. And I talked about this thin slicing of storage. There are workloads which need really very little storage, but they need storage. And if you won't be able to take very small pieces, you won't be able to take EBS volumes of small number of megabyte and pay less for this. So if you're having your single application with using a single volume on EBS, it's one thing. If you have multiple applications that you move to the public cloud, you could have very good use of the storage system there by doing thin slicing and utilizing the AWS resource better or cheaper for you. The public cloud structure. So we have multiple public cloud providers AWS, Azure, GCP, IBM, Alibaba. We have regions. Now I'm talking with AWS terminology, so regions are geographical areas. So we have USC several, US West several, APAC, European, multiple regions. Within regions, we have availability zones, which are data centers, and the numbers. Typically, in most, we have 3. We have between 2 to 6 today. In Amazon, I'm really talking about 3 or more AZs. I'll talk a bit about 2 in the end. The problem with 2 AZ availability zones is that it's not real protection against availability zone failure, because you will have split brain. You can't have, if you have the quorum of your Paxos cluster on the failed availability zone, then you lost your application, so you need to put arbiter outside. So you can't keep it within a single region if you have 2 AZs, but I'll talk a bit about it. So this is just an example. So we have in North Virginia, it's an older diagram, but you have like 4 availability zones in North Virginia and 3 in Oregon, and so on and so forth. So the public cloud economy. The public cloud economy is all about replacing CapEx with OpEx. You don't buy your assets, you rent them. You pay for what you use. That's everything. Well, I'm not an accountant, but this is the main reason. This is why organizations love it. They don't need to pay now and say, okay, but I'm going to use it for 3 years and I don't know how much I'm going to use it. It's much easier to say, okay, this is what I use, this is what I paid for. But you pay for everything. So you pay for your compute, either you rent nodes, or in the case of serverless, you pay per execution of a function. You pay for storage, there are different storage types, various cost structures, but you pay for everything that you use. You pay for your network. And we'll talk about it. Cross-AZ network is expensive. If you want to be able to have highly available application across AZs, the cross-AZ network is expensive. You're going to pay a lot for it. You pay for application. You could get everything as a service today, almost everything as a service, but you pay for it. Doing replication of your data costs you money. You could have your database development tool, whatever, but everything costs you. And this is something that we are not used to it a lot. So efficient public cloud application minimize resource usage even when resources exist. We're here in storage conference. If we have storage appliance, and in the appliance we have 10 gigabit network interface, and this is enough. We are using 6 gigabit. 10 gig is enough. We don't do anything because we have a 10 gig card and we use only 6 gig. But this is not correct necessarily for the public cloud, because if we could reduce the network traffic from 6 to 4, we are going to save a lot of money on the cloud. This is something that when we had enough hardware, we never thought of reducing our compute or our network or anything. This is about public cloud. We need to think about it. We need to optimize all the time. So reducing the storage costs. So what we have here. So device selection. If you talk about storage system, we need to think about our devices. And this is really, really tricky because we want the cheapest possible solution, and Amazon wants, or any cloud provider wants that we pay as much as possible to them. So the first thing is use instant storage instead of EBS. EBS is easy to use. It's easy to consume. All nodes could consume it. You could have free choice of the, relatively free choice of the nodes. It can move within the AZs from node to node if you want it, whatever you want. But EBS is storage, and storage system uses storage to store its data. It's expensive. And it's limited by the IOPS. So We want to use instance store. Instance stores are just devices that connected to the instance, but are limited to special instances. So it's cheaper, it's more performant, you could get way more IOPS out of this, it's just devices connected to your instance. Oops, but it's less reliable. Because, first of all, it's devices, and second, it's related to the node. If you need to move, the node need to move physically. Your load moved physically from node to node, you lose everything. So what? We are a storage system. We know how to handle failed devices. This shouldn't be a problem for us. But there are other problems. We need to be very careful when we select what we get. Again, we have a realm of a multi-dimensional realm of requirements. We have the compute with the nodes, we have the capacity that we get with each node, we have the network interfaces, we have the memory, and we get only a very sparse number of points over there. And spoiler, it's very difficult to get what you need. Usually you need to buy something which is, we need that everything will fit us. So we see that either we need to buy more CPU because we need more network, or we need to buy more network because we needed more memory or anything. None of the points would be, unless we're very lucky, none of the points would be our sweet point. But we need to choose and see what we could use and what we can use. But this is very important. On storage system, this is one of the main points for the cost that we want to save. If there are requirements to use EBS or to use any storage of the cloud provider, use it sparingly. It could be that you want something really, really reliable, even on a single AZ. With two AZs, for example, as I said, we have problems with two AZs when one fails. Maybe you want to use EBS. But if you have the requirements, use it sparingly. EBS is expensive. If you need EBS, consider using less replicas or erasure code schemas or whatever to minimize the use of EBS. So the first thing is be very careful when you do selection. Again, I do not bring here numbers because the offering change all the time. And we need to be, we need to be very careful, and we need to be very flexible to change what we decided to select, because it's the offering, it's very dynamic area. So that's, we need to be very careful, but that's the first. The second tip would be network optimization, and again, the key part here, and this is really an important part, is that the cross-AZ communication is really, really expensive. Really expensive. If you want to deploy high availability system on multiple AZs, we need to be very careful on this. So minimize cross-AZ communication is really very, very important tip here. It all started for us, for Ceph, from implementing read affinity. The whole blog that I talked in the beginning was about implementing AZ read affinity, which means I want to be able to read if my client runs on a specific AZ, I want to read from the data from the same AZ, not having to jump to a different AZ to bring the data. So this is, if you could do it in your storage application, this is very important tip. This is something that we are going to very soon put into Ceph. It's in the final steps. That was the first thing. That was what triggered everything. So implementing read affinity is very important. Use compression of the network where appropriate. If you need to do cross-AZ communication and you can compress it, compress it. It doesn't matter that it could be that Amazon compresses this on the wire on its own. They charge you before the compression. So if you could compress your workload, you're going to save a lot of money for your customer, whoever is paying for this. Consider alternative topologies which minimize minimize the cross AZ networking. So this is an example. So this is an example that comes from what I said I will not talk about, but I'm going to talk about, I said I talk about a bit, is 2AZ domain. So if I have only 2 availability zones, at least for Ceph, it's very difficult to work with 3 copies on 2 AZs, because when something fails, some of the data remains, with AZ fails, some of the data remains on a single copy. So our natural solution is to think about 4 copies, 2 copies in each AZ. So here is the AZ barrier, and here I marked with red line is the cross AZ communication, and black line is inter-AZ communication. So this is the native way to do it. But if we are putting a gateway over there, that's what we have here. We have here a gateway. We could reduce this line to 1. So instead of having 3 arrows, we have 4 arrows now, but only 1 red arrow. This is something that is going to save a lot of money. So that's what this means. Don't pass the same data twice between availability zones. If you know it's the same data, don't pass it twice. It's very expensive. Try to do everything that you can to minimize the cross AZ communication. So this is an example of different topology. It required new component. Obviously, it has to be highly available, everything, but it's worth the money, because the money for cross AZ is per use. It's all the time. It's not one time that you pay for it. You go on paying all the time. So it's worth a lot of money to invest one time in development in order to save it. And if you can do it cheaply in terms of your investment, or in terms of CPU investment, or you have the resources to do it, even save network in the availability zone can help a lot. Especially it can help a lot because network bandwidth on the node is an expensive, very expensive resource. Especially when you are working with NVMe devices, we see that our bottleneck usually is the network. So when we need to decide on nodes, we need node with enough network bandwidth. If we need so the cost of the node would be by the bandwidth on the NIC and not by the number of the devices or the computer, whatever. This would be the thing that brings everything, the prices up. So if we could save a network bandwidth, we could have smaller nodes and cheaper nodes. Again, this is something. And this is, by the way, sorry, this is hidden information. It's not easy to find it on AWS documentation. It's not easy to find it in Google. It requires, digging deep into this to find exactly what are the limitations and how much you have to pay for them and doing this. So this is something I really, really recommend looking into the very, very small and finest detail of everything that you plan to do. If you plan to take a node, look at the spec of the node exactly to every letter. If the network bandwidth is up to 25, look what up to 25 means. Up to 25 means 25 gigabits per second means usually something like this. In Amazon, I don't know, in others. It means that it will provide you 25 gigabits per second for 30 minutes every 24 hours. In the rest of the time, it will provide you something else. What? It depends. Not all the nodes the same number. Could be, instead of 25, 2. So be very careful when you look at this. Be very careful when you see something up to, and look at the finer prints, because it's very, very difficult to understand the pricing model. I don't claim to understand it. But so this is very this is something that's easy to fall and ignore when you start doing the development, but eventually it's going to cost a lot. Elasticity. So the thing about when we move to the cloud, we need to right-size our deployment. If we have empty system, if we design system for 100 terabytes and we put 50 terabytes in this, we're in a problem. We pay way too much to Amazon. Amazon loves us, but we pay way too much. We need always to be able to right-size the system, and this means also to downsize the system. Usually storage systems are not used to do downsizing. We have the disks. Why downsize? No one will take the disks out of our appliance and put it somewhere else. Well, this is not the case in public cloud. Give the disks back to Amazon and save money. So this is a very important thing. Use relatively small building blocks. You don't want small number of large building blocks because then doing reduction or enlargement is not good. And I'm not saying what is small and what is big, but if you have 3 building blocks, you want to add 10%, you need to add 33% because you have 1 building block this size. You need to have large number of building blocks so you could play with them with relatively small units. So if each node is terabyte and you have 10 terabytes, 10 building blocks to start with, you could reduce 1 terabyte, add 1 terabyte, that's okay. If you have 3 building blocks for 1 terabyte and you have a system which is 50% full, maybe you cannot remove it because 50% out of 66% may be too much for you. So use, again, depending on the deployment, but choose the right number for you, the right number of building blocks, the size of your building blocks. So we are able to do tight scaling because that's how to save money. Enable downsizing. Again, it's not common, but it's not something that is that we can get out of Amazon. You cannot decide to take that we took EBS of 2 terabytes and say, okay, we're not using this, let's make it 1 terabyte. They won't let us do it. But we can empty this device, we can take all the data out and return it back to Amazon. So, but reducing the size, which you are not using, is important. The units are either EBS volumes or storage nodes, or node with all the devices in the node. You cannot, at this point in time, you cannot return a single device out of the node back to Amazon. You don't get anything out of it. You need to give back the entire node. So these are our unit, EBS volumes or storage nodes. And they enable downsizing for the customers. If you provide service to your customers and they pay you per the capacity, they have exactly the same problem. They want to be able to be elastic and to enlarge and reduce what they take out of you. So if you want to be friendly to them, you need to be able to enable downsizing for them. If you want to be like Amazon, we may not do it. But one of the reasons to take storage systems instead of using the cloud-native storage systems, one of the main reasons is to provide features that do not exist in the public cloud. And this is one of the things that you can do. We can provide downsizing for our customers so they pay for what they actually use and not for what they allocated. And again, this is for block because you pay, because it's different for files and storage in this specific, and the object in this specific area. You pay for what you use, not for what you allocate. But on block, you pay for what you allocate. So key points. Elasticity. This is the obvious, but this is the key. The key for successful implementation is elasticity and right sizing. We pay for what we use. We need to use as little as possible per our deployment. We need multiple deployment options. The pricing models change without notice. Things change, the rules of the game change as we started at the beginning. If we are not flexible in terms of a multiple deployment option, then while everything is okay for now, we release our system, and 2 months from now, something changed within Amazon, and we are not efficient again. So we need to think about this. We need to be efficient all the time and with multiple deployment, because we don't know anything about the pricing tomorrow. We know at most about the pricing today. Maybe we don't know enough even today, but we don't know anything about tomorrow. It changes. So this is important. And think OpEx. We need to optimize on more dimensions, and we need to optimize on what we are not used to optimize, because it's not technical. It's not a technical thing. It's a pricing. As developers, we have the machine. We use it. As a public cloud developers, we should develop to use the smallest possible machine available, not use what we have, but optimize everything so we could use something smaller. Thank you very much.